just as we had a couple different types of regions when we're working with double integrals, we're looking at the regions in the xy plane. With the same sort of a situation here when we're talking about solids. So there are three different types of solid regions. And in reality, it's all one type that's just simply rotated differently in 3 space. So the first one, a type 1 region. See if I can draw something that's reasonable here. So I have some region in 3 space. Maybe something looks something like that. Of course, it comes down, and down here I need the other side of it. So pretend like that's my region in 3 space. So this is what I'm going to make reference to as, I'm going to call this E. And it's going to have a projection onto the xy plane. It's going to look, something like this. And this is this region D. Now I'm going to define this as having an upper bound of, say, U2 of xy. That's what I'm going to think of as this surface up here. And then U1 of xy. So I'm going to think of this as this bottom surface. And the idea here is that this region lies between these surfaces of two continuous functions in xy. And that's my U1 and U2 that I labeled. So I can define E as being the set of x, y, z such that xy is in this region D down here on the xy plane. And I hope I left myself enough room. U1 of xy is less than or equal to z, which is less than or equal to U2 of xy. Barely got it in. And in case you can't read that, that's U2 of xy. That's what that says right there. So this is the solid E, and I'm going to add to this where D is the projection of E onto the xy plane. Now, in turn, D may be a type 1, type 2, or neither. One of those combinations of type 1s and type 2s. So D could be a type 1 or type 2 region, and then E could be a type 1, and I'm about to talk about type 2 and type 3 solid. Now, a type 2 solid region is the exact same idea. Let's see if I can draw this, but we're just, the projection is simply on a different plane. So I'm going to draw it at an angle like this. I think I can probably do it a little bit better. Here's y, x, z. Just make it kind of like a cylinder. So here's my solid E. Oops, it comes back that way. Okay, here's E. And then this projection D is over here on the YZ plane. So these two continuous functions that result in surfaces that bound it, this top one, the U2, is not going to be a function of YZ, and U1 is also a function of YZ. So we can say that the region, or the solid E, is going to be the set x, y, z such that y, z is in D, and u1 of yz is less than or equal to x, because x is now my third dimension here, which is less than or equal to u2 of yz. Now this last region, again, all I'm going to do is rotate this thing. So let's see if I can draw this. If I make this z, y, x. So I'm going to have this thing up here. I'm going to draw it kind of cylindrical again because it's a little bit easier to draw. You kind of get the idea. Okay, so here's E. And that's floating around there in 3 space. And then the projection, D, is now on the xz plane. That means this continuous function here is giving me this top surface, so to speak. U2 is going to be a function of xz, whereas U1, also a function of xz, would represent this bottom surface. So I can describe this solid, the solid region, as a set of points x, y, z, such that now I'm going to have xz is in D, and u1 of xz is less than or equal to y, which is less than or equal to u2 u2 of xz. So these are the 3 types of solid regions, and basically, like I said, they're all the same. It's just a matter of where is their projection. If the projection's on the xy plane, then it's the same thing we've been dealing with. But we can twist these around in 3 space such that the projection could be on any one of these planes, and the process is identical. It's just a matter of really relabeling what we typically think of as xy may now be zy or xz or something like that. Now for each case, regardless if you're dealing with a type 1, type 2, or type 3 solid, you must decide if the region D, you need to decide if the region D, the projection onto the appropriate plane, is of type 1, type 2, or a combination. So you need to decide how to deal with this region D.